welcome to Chem Vid. Today we're going to talk about separation techniques for physical and chemical mixtures. Alright? So last time we talked about matter, and matter could be put into two groups, pure substances and mixtures. And when I mixed pure substances together, I got a mixture. That was a physical change. Then my pure substances, I have elements, the basic building block, and when I put them together chemically, two or more elements together chemically, that's called a compound. Okay? So we have two different kinds of changes here. Now all mixtures are physical change. They're a homogeneous or a heterogeneous, meaning you can see the difference, which is hetero, or you can't see the difference, which is homogeneous. Alright? So now that we have that, I want you to try the notes. Physical separation. Go ahead and in this box I want you to draw two different things, okay, mixed together, a heterogeneous mixture. Then I want you to draw a separation in these two boxes. Go ahead and try that. Okay, so for me, I chose to do just regular old orange boxes, and when I separate them out, I have orange boxes over here. This is supposed to be a box, kind of. Okay, there we go. And then I have the circles over here. This is what we call a physical separation. Nothing has changed. They're still the same pieces. I've just moved them into separate containers. Alright, so that's what a physical change is. A physical separation does not change the connectivity of atoms. It just separates it into two different locations. Alright. So, what are the two different types of mixtures? Homogeneous and heterogeneous. Those are the two different types of mixtures. Now, you may recall, homogeneous mixtures can also go by the name of solution. A solution means a homogeneous mixture. And over here, I got this table out of your book, but these are some of the mixtures or solutions that can happen with the different phases of matter. So a gas in a gas, all around you you have air, and that's a mixture of nitrogen, oxygen, carbon dioxide, all sorts of gases are in the air, and they're mixed together. Where it gets a little tricky might be a gas in a liquid. So when you have a soda pop, you have corn syrup and water, and that's what the liquid is. And then they mix gas, CO2, into the soda pop to give it, that fizz. That's when a gas is mixed into a liquid. Whereas a liquid mixed in with a gas is like your breath. If you hold your hand in front of your face and breathe on it, you're going to feel some moisture. That's because your breath is mostly gas, but it has a little bit of your saliva in the gas. And so it's a liquid mixed into your gas. Alright? Liquid and liquid is like water and that miso flavoring stuff that you put in there to make it taste good. So you put that in there, liquid and a liquid are mixed together. Solid and a liquid is when you can have salts mixed into water, like seawater. And so any kind of salty water, that would be a solid mixed into a liquid. And it dissolves. And then a solid and a solid, the most common one we have is an alloy. When you mix two metals together and you get a new substance. Alright? So those are the different types of solutions. Now, let's figure out how we separate them. So, when we have these solutions, we want to get them apart sometimes, alright? So these are the main techniques: filtration, distillation, crystallization, sublimation, and chromatography. These are the main ways you can separate a mixture of some kind, okay? So let's start off with filtration. Filtration is when you separate out something based on size. The objects are two different sizes, and so therefore you can use a filter, you can use a funnel, something like that to separate it. You probably know filtration as when you're making spaghetti and you put the spaghetti and the water through a colander, and the water goes through but the spaghetti stays trapped, that's because they're two different sizes, and I filtered out the water. Okay? So make sure you draw, or write down the definition and draw an example so you know what these are. Okay? Alright, distillation is when you are separating a substance based on boiling points. Okay? So this little contraption right here allows us to separate two different liquids based on boiling points. So let's say that in this container right here, I have alcohol mixed with water. You guys have isopropyl alcohol at home. You use it to clean wounds. And so they're both clear. Isopropyl alcohol is clear. Water is clear. So you can't really tell that there's a mixture there at all. But the thing that makes alcohol and water different, alcohol has a really low boiling point, and water has a really high boiling point. So when I heat this up, when I put this solution over a flame, the alcohol is going to start to rise up here, and then it comes down this tube, and it's in a gas form. Okay, so it's evaporated, and now it's rising up. Well, this part right here, if you see this lovely little light blue, it circles the tube, the glass tubing, that's called a water condenser. And the water condenser cools down the substance that flows through here. So the alcohol is going to come through here, and as the alcohol goes through the cooling, it turns back into a liquid. And then the alcohol falls back in, and I'm left with alcohol on this side, and water, just water, on this side. And the reason why that's possible is because they have different boiling points, and so they are able to be separated like that. That's called distillation. Let's try crystallization. Now, crystallization is a little different. Crystallization is using freezing points in order to change. So in this picture, I have water, H2O, and let's say I have, alcohol again. Alcohol and water have different melting points, okay, or different freezing points. Water is going to freeze faster than alcohol. Alright? So when I have alcohol and water mixed together in this container, if I were to put this in a freezer and freeze it to 100 degrees Celsius, that would mean that my water would freeze, and it starts to freeze and makes these crystal patterns inside of it. Okay? So my water would freeze, but my alcohol would stay a liquid. So then I could take this flask, and I could pour it through a filter, keep the crystals, and the water would be separated from the alcohol. Alright? Now, crystallization also is used for the term when you return a substance to its normal state, when it's a crystal. For instance, salt water. If I mix salt with water, it turns into a homogeneous mixture. I can't tell the difference. But if I put it over a flame, salt will not melt, okay? But the water will evaporate. So the water starts coming out, okay? And what I'm left with is salt in the dish, and the water turns into a vapor and escapes. Okay? A gas, I should say. So the salt left over recrystallizes and turns back into the crystalline structure that salt usually has. So this is what we call recrystallization. So there are two main types of crystallization. The first one, crystallization, refers to using freezing points to separate out a substance. And recrystallization is when you're getting back a salt out of water, or a substance out of water and recrystallizing. The next type of separation, physical separation, is sublimation. Sublimation separates things based on when they will sublime. So sublime means going directly from a solid into a gas, okay? It skips the liquid phase. So if your substance that you're trying to separate sublimes, you can put the substance right in here, and then you'll heat it up, you'll add heat to it. As the substance heats up, the substance that sublimes is going to turn into a gas, and it's going to float up to here. This is what we call a cold finger. It's a piece of glass, and we run cold water through it so that this guy is now really, really cold. So when the gas hits this, it turns back into a solid. Now I have the solid that sublimes up here, and the solid that doesn't sublime down here. So that's another way of mixing, or separating mixtures. The next way is chromatography. Chromatography is based on the ability to travel across a material, okay? So when you guys have probably spilt water on a piece of paper and you notice that your pen or your marker starts to spread up the paper. That is because of polarity. Water is polar, and so it grabs onto the polar ink, and the polar ink is then dragged up the piece of paper, like you can see on these examples right here. So this blue color right here is made up of two colors, purple and a lighter blue. If I were to put this paper in water, the water would travel up the paper, and whichever substance is more polar or more willing to travel, it's going to grab onto the water and it's going to travel up farther than the other one. So in this case, blue travels up really quickly. Purple takes a little more time, meaning that purple does not want to travel as quickly. It's not as polar. All right? In this example, blue is moving up quickly, just like the other one, and yellow is not traveling as quickly. But yellow and purple seem to travel about the same amount. Whereas red has a dark red color and a yellow color, and they don't really separate much, meaning that they're about the same polarity. They're going to travel about the same. So the way a lot of chemists use chromatography is by getting a burette. That's what this object is called. They put two substances, we're going to call them A and B, up here at the top. Then they start putting in a solvent, and a solvent is the liquid that will flow through, that will attach itself to one of the substances, okay? So the solvent is put in here, and as the solvent travels down the tube, it's going to grab onto the substances and pull them down. So if you look, A is constantly moving faster than B, which means that A likes the solvent. Okay? It is attracted to the solvent and is happy to move quickly. Then as A gets down to the bottom, we're able to capture that in another container, switch containers, and then capture B. So that is how chromatography works. Go ahead and see if you can use our separation techniques right here and see if you can separate out these mixtures. Go ahead, push pause, and try that out. Okay, so for two colorless liquids, I could use distillation. Change in boiling point, I could distill those out, and the one with a higher boiling point would come out quicker. A non-dissolving solid mixed with a liquid. Well, a non-dissolving solid is like marbles and liquid. So if I wanted to separate marbles and liquid, I could use filtration. Put it through a strainer, separate it out. Red and blue marbles of the same mass? Well, I could always just pick those out. Manual separation works just fine. We will be covering chemical separation in class, so we are done with the notes for today. Nice job, and we'll see you next time.